All right, let's work with some inequalities. I just made this video and realized that I wasn't recording. So I did all this work and now I have to redo the whole thing because I forgot to record. But let's work with an inequality. That's an inequality. The greater than, less than, greater than or less than signs are inequality. There are 4 different kinds: greater than, less than, greater than or equal to, less than or equal to. Okay, those are the 4 signs. The greater than signs will be dotted lines. The greater than or equal to or less than or equal to are solid lines. In this one, it's a dotted line. So let's graph this sucker. It graphs just the same as a regular equation. My y-intercept is plus 5. So I go to the y-intercept, make my first point at 5. My graph travels down to right 3, down to right 3, down to right 3, down to right 3, down to right 3. You don't need to go that far. Do a couple forwards, a couple backwards. Up 2, back 3. Up 2, back 3. Okay, there's my line. I could leave it like that, or I could make a dotted line that goes through it. Big whoop-de-doo. Doesn't matter. Partially done with this. I now have to find all the points that could be placed into this for the x and the y values that would make this statement true. Now, what does that mean? Let's choose a point from our area, our big chart, our big graph here, our slope intercept form here with our coordinate plane. Let's choose the easiest point. Point 0, 0, the origin. I take the 0, 0, and I put the 0 in for the x, and I put the 0 in for the y. So this turns into 0 is greater than, what's negative 2/3 times 0? Correct, it's 0. What is 0 plus 5? It is just 5. Now this statement, I can look at it and go, is 0 greater than 5? Well, I hope you're not saying what I think some of you may say, but this is not true. This is not a true statement. That means none of these points down here could be placed into the x and the y value in our original inequality and make it a true statement. That means everything up here would work. All the points up there would work. Let's test that. Let's take this point right here, 5, 5, and put it into this problem. Let's put the 5 in for the y. So it turns into 5 is greater than. It is negative 2/3 times 5. Okay, negative 2/3 times 5 over 1 should turn into negative 10/3. Okay, plus 5. Okay, negative 10/3, that's basically negative 3 1/3. This is going to be like 2 2/3 as an answer for when we work this out. Is 5 greater than 2 2/3? Yes. That's why it works, okay? You don't need to test it unless you feel that you made a mistake. But the reason that we use the origin to test it is because it should be an easy test to work out. It turns the y into a 0. It turns the x into a 0. All you have to do is look at your inequality and what the two numbers are and see if it's a true or false statement. That's why we choose the origin, because it's not a number that turns into some crazy fraction like negative 10/3. Make sense? Good job.